Alright, this is the video for section 7.6 on finding rational roots. First thing I want to do is give you a definition again for rational roots. Remember, rational means that these will be whole numbers or fractions. They won't have square roots in them. Those are irrational roots, and they won't have I in them because those are complex roots. So our goal today is to, if you're given a polynomial, to find all of the whole number or fractional roots that will go into it, all of the answers to that problem if that problem equals 0. Now, we have a shortcut here to find all of the possible roots. Okay, now possible means that not all will work. Okay, only a few of these will work, but not all of them. So this is a shortcut to find all of the possible rational roots for a polynomial. First thing you want to do is look at the constant term. And then you want to list its factors. Okay, remember, factors are numbers that multiply to whatever number you're looking at. And those are called your p's. Alright? After you've listed all of those out, then you're going to look at the leading coefficient. You're going to do the same thing. You're going to list its factors. And those are called your q's. So look at the constant term, list all of the factors for the constant term, those are your p's. Look at the leading coefficient, list all of its factors, and those are your q's. And the last step is to make fractions of p over q. And then any fraction that you come up with, and you need to reduce them if you can, are possible roots to the problem, possible rational roots. We've got two examples here. First one is f of x equals 3x to the fourth minus x cubed plus 4. So what we want to do is we want to find our p's. And the p's come from the constant term. Our constant term in this case is 4. So we want to list all the factors of 4. Well, we have 1, 2, and 4 because 1 times 4 is 4, and then 2 times 2 is 4. Now, one thing that we have to remember is that we can have negatives also, because if I have a negative 1 times negative 4, that gives me positive 4 also. So really, we need to include plus minus for all of these numbers. So we have plus and minus 1, plus and minus 2, plus and minus 4. The next thing we need to do is list our q's. And the q's come from the leading coefficient, which in this case is 3, and we want to list all of its factors. Well, the numbers that multiply to 3 are plus and minus 1 and plus and minus 3. Make sure you put the minuses on there because negative 1 times negative 3 does give you positive 3, which is what we want. So now we list them out as fractions. We list out p over q. Well, I'm going to start with this 1, and I'm going to do 1 over 1 with the plus minus out in front. I'm going to do 1 over 3. And then I'm going to jump to the 2. We'll have plus and minus 2 over 1, plus and minus 2 over 3. Then we jump to the 4, and we do plus and minus 4 over 1, plus and minus 4 over 3. And you should reduce all those. So plus and minus 1, plus and minus 1/3, plus and minus 2, plus and minus 2/3, plus and minus 4, plus and minus 4/3. Now those are all of your possible rational roots. Again, not all of them work. They're just possibilities. I've got another example here. F of x equals 7x to the third plus 2x squared plus 21x. And there's something special about this one. Notice that there's no constant. There is, however, a greatest common factor, and we want to take that GCF out first. So we'll have x times 7x squared plus 2x plus 21. We're going to set that x equal to 0, and that's actually one of the answers. And then we have 7x squared plus 2x plus 21. Now we have our constant term and our leading coefficient, so we list out our p's, which would be plus and minus 1. These are the ones that are the factors of 21, plus and minus 1, plus and minus 3, plus and minus 7, plus and minus 21. We list our q's, factors of 7, plus and minus 1, plus and minus 7. Now we list out our fractions, p over q. Well, we have 1 over 1, which is plus and minus 1. We have 1 over 7, which is 1/7. 3 over 1, which is 3. 3 over 7, which is 3/7. 7 over 1, which is 7. 7 over 7 goes back to 1, and we already have that listed, so we don't need to list it again. 21 over 1, which is plus and minus 21. And then 21 over 7, which goes to 3, when 3 is already listed. So if there are duplicates, we don't need to list them twice. And there's our list of possible rational roots. Now the next thing we're going to do is we're going to actually find those roots. Okay, so we've listed out all of the possibilities. We're going to go through and find them. And the question we want to ask ourselves is which ones will work? Of the list we made, which of those numbers in that list is going to work for our problem? So the first thing we want to do is we want to list the possibilities, which we've already done. Okay, you will repeat those same steps that we just did for those two examples. And then the second step is that you're going to guess and check. Okay, and to do that, we're going to use synthetic division. Now we use synthetic division instead of long division because synthetic division is quicker. But our goal is to find all of the rational roots that will work in the problem from the list that we've come up with. So I've got an example for you. F of x equals x cubed minus 3x minus 2. So the first thing we want to do is list out our p's and q's. Remember, our p's come from the constant. Constant's 2 in this case. Factors of 2 are 1 and 2. And then the q's come from the leading coefficient. There's no leading coefficient written, so it's understood to be a 1. And that means our p over q's, there's going to be few of them this time, not as many as there were in the other problems. 1 over 1 is 1. 2 over 1 is 2. So we really have 4 choices here to choose from. We have positive 1, negative 1, positive 2, negative 2. So we're going to set up synthetic division. We have a shelf. We're going to list out our coefficients. Remember, if you are missing things, you need to list out placeholders. So I'm going to start with a 1 for the x cubed. There is no x squared. The x would be negative 3. And then the constant's negative 2. Now we're just going to guess and check. You pick from the list of p over q's that you've come up with, and you see if they work. And if it doesn't work, you go back and try again. So let's just pick positive 1. First thing in my list. Try synthetic division. Bring down the 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. Be negative 2. 1 times negative 2 is negative 2. Our remainder is negative 4. So no, 1 doesn't work. Since it doesn't work, we go try something else. Let's try negative 1. Coefficients will still be the same. Draw a line. Okay, bring the 1 down. 1 times negative 1 is negative 1. 0 plus negative 1 is negative 1. Negative 1 is positive 1. Gives us negative 2. Negative 1 times negative 2 is positive 2, so our remainder is 0. So this one works. Negative 1 is a factor. That's one of them, or one of the roots. It goes into the problem. Now what we can do, you want to get it down to 3. And when it's down to 3, you can rewrite it as a polynomial, a depressed polynomial, and then you can try to factor it. So we draw our x, negative 2 on top, negative 1 on bottom. Two numbers that will multiply to negative 2 but add to negative 1. Those would be negative 2 and positive 1. We could use our shortcut, so x minus 2 equals 0, x plus 1 equals 0, so x is going to be 2. and x is going to be negative 1. So if we want to list out all of our rational roots, we list out anything that worked in the problem. We have negative 1, 2 worked, and then negative 1 worked a second time. Those would be the same answers on the end, so it would just touch the x-axis. It wouldn't intersect it more than once. It just touches it there. And then 2, it would actually cross. But those would be the answers to our problem. All right? Let's try one more example. This example is a little longer. F of x equals x to the 5th plus 10x to the 4th plus 33x cubed plus 38x squared plus 8x. Okay, notice that there is no constant. We talked about this earlier when we were listing out the rational roots. If there's no constant, we're going to factor out a GCF, which in this case is x. So we have x out in front, x to the 4th plus 10x cubed plus 33x squared plus 38x plus 8. X is going to equal 0 out in front, and there's one of our answers. We need to keep that. And then we're going to use synthetic division on the rest of it. Plus 8. I'm going to get you started, and then you are going to finish this and bring this to class next time. I'm going to help you get your P and your Q's. P's are the factors of the constant. Our constant is 8 in this case, so plus and minus 1, plus and minus 2, plus and minus 4, plus and minus 8. Our Q's come from the leading coefficient, which is 1, so plus and minus 1. And we make fractions out of them. In this case, everything's over 1, so it's just going to be plus and minus 1, plus and minus 2, plus and minus 4, plus and minus 8. We set up our shelf, list out our coefficients. Remember, we're using this one after we factored out the x. So we're going to have a coefficient of 1 on the x to the 4th, and then a 10, 33, 38, and 8. Draw a line. Okay, and you are going to pick which numbers you want to put on the shelf. You have 8 choices there. Positive 1, negative 1, positive 2, negative 2, positive 4, negative 4, positive 8, negative 8. All right, I'm going to pause this. I'm going to let you pick one. See if you can come up with a number that works, and then come back and check it. All right, one number that works is negative 2. And if you came up with that, good for you. Okay, we're going to draw our arrow. We're going to bring that first one down. 1 times negative 2 is negative 2. 10 minus 2 is 8. Negative 2 times 8 would be negative 16. 33 minus 16 is 17. 17 times negative 2 would be negative 34. 38 minus 34 is 4. Negative 2 times 4 is negative 8, so our remainder is 0. So 2 would be a rational root to the problem. Now, what you're going to do, you're not going to go back to the original. You're going to keep trying, but you're going to use your new set of numbers this time. And your goal is to get to 3 terms. Okay, because at 3 terms, you'd have an x squared, an x, and then a constant, and you can factor that. So keep using the numbers that you get as answers and work toward getting 3. Here we had 5, we're down to 4 now, so we'd have to find one more root, and then we'd have 3, and you could factor those 3. Now what I want you to do is see if you can come up with the root on the shelf, rewrite your depressed polynomial, and then try to factor it. Now make sure I only want rational roots. So if you get a square root in there, those wouldn't be rational, those are irrational, so we wouldn't include them in the answer. Now, one other thing I want to point out is that negative 2 worked. Negative 2 could work again, but anytime if it doesn't work, if it didn't work this first time when you tried it, then it won't work anymore. Okay, it won't work at all. If it does work, it could repeat. You could have something like a double root where it's listed twice. Alright, so keep that in mind. I'm going to let you finish this problem and bring it to class next time. If it doesn't work at all, if you come up with a number that doesn't work in the problem at all, it will never work for that problem. But if you find one that does work, it could repeat. So you need to finish this and bring it to class next time, along with any questions you may have about anything that was in this video. And those are your notes for section 7.6 on finding rational roots.